or I mean, do exactly the opposite of what I say, because that's what we do here. Okay, it is fantastic to have you here. It's been 2 years since we had our last in-person.
It's been that long since we've done an in-person meetup that I have never done an in-person meetup for Serverless Days.
Yeah, we haven't even known each other that long.
No.
This is maybe the first time we ever met.
Yeah.
Possibly. In any case, it's great to see you, and some of you apparently we're seeing again because you've been part of the community for so long that you remember how things were back in the olden days. So it's really great to be here. And yeah, I'm gonna just start with the slides really quickly. It's not doing the thing with the slides.
There we go, it's going.
Oh, well, okay. So Serverless Days, the meetup edition. There was a conference. There used to be a conference. There will be a conference again once we all recover from burnout. Or, I mean, you can also join the organizing team and help us, put on the next conference. That would be great because it was a lot of fun.
Help's always welcome.
Absolutely. So right now we're at the meetup edition, and this is the first hybrid meetup. So we're here, but we're also streaming it to Twitch and YouTube, and people on Twitch and YouTube can still ask the questions either in the comments or on Discord. So we will have someone monitoring that as well. And so we're going to just try to have everything interactive here. And the plan is, by the way, to make it hybrid, alternating with online. So next month we're going to be online again. Oh, that's a good cursor position. Well,
so we maybe change that one.
Well,
it's always fun when you're doing stuff for the first time, like trying to do the hybrid.
Well, it was a very nice touch. Anyhow, so usually our meetup is the first Wednesday of the month. That's how you can remember, except this month, because tomorrow's Remembrance Day. We didn't want to clash with it. So this is the only exception. Usually we're first Wednesday of the month. And thanks a lot to IKEA. Thanks a lot, Jan, specifically for organizing this, and to the great organizing team and the kitchen staff and the IT and operations staff. And like that was great. Thanks a lot. This is a great place. Yeah. This is a great place to have a meetup. So thanks a lot. Yeah, so you can, as I said before, you can join our Discord to talk with the community members. This time the speakers probably won't be on Discord. I mean, maybe they want to be, but unfortunately they're here. So if you have questions, you can put them there on the Discord and we will relay them to the speakers here on stage.
Well, not unfortunately that they're here. Awesome that they're here.
Yes, well.
And unfortunately.
Exactly. Well, unfortunately for some people, fortunately for us. And also, we ask you to please take a look at the COC if you haven't seen it yet. And obviously, the COC applies to all our spaces, so here, but also Discord, Twitch, and YouTube, and technically also Twitter. So just make sure that you familiarize yourself with the code of conduct and follow it. Yeah, I think Stace, this is where you come in. Yeah. Oh, you know what we didn't do? We did not introduce ourselves.
We didn't introduce ourselves.
Oh my God.
Lian, would you like to introduce yourself quickly for us?
Totally do that. Okay, so my name is Lian. I have been organizing Serverless Days from the very beginning back in 2018, 2019. I'm not sure anymore. It's been so long. 2 lifetimes ago. So right now I'm a developer advocate for Loft Labs, which is pretty ironic. And I think we all laugh about the fact that I have never done anything with serverless in my entire life. I'm a total Kubernetes person, but we're not going to hold that to my disadvantage, I hope. Stace, how about you? What are you doing?
Me, I'm Stacey Cashmore. I am Tech Explorer DevOps by Omniplan. They make financial advice software just down the road from here, over there, somewhere in Amsterdam anyway. I'm also not actually a serverless person. I play with serverless, but I don't really use it in my day-to-day job yet. And yeah, I started helping with the organization here, like I say, midway through the pandemic. Partly because I wanted to get involved with the community on this side of the stage, and partly because I just want to learn loads of stuff about awesome serverless things that are going on. So yeah, welcome everybody. And we have a blank screen because blank screens are awesome. We have an agenda. So first of all, we have Luc van Donkersgoed. Did I say that right? Yes. I didn't destroy it with my English. Talking about confidently building cloud-native applications with serverless integration and testing. Then we're going to have a short break because we're in person and we can have short breaks again without like stressing. And then we're going to have Jerry McCollum talking about serverless at IKEA. And before we move on, I just want to say to everybody here today, thank you so much for joining us, because when we said we were going to do in person and we went back and forth, is it too soon? Are people going to come? And I think when the meetup was up for a couple of weeks, we had like 4 people signed up or something. And
I think 3 of us were us.
So thank you all so much for coming out tonight. We've got some amazing speakers for you. And please, let's give it up for Luke.
Thank you. Let me just turn on the laptop.
And hopefully we have... give it a screen. Yay!
All right. Well, hello, and thank you for being here. Thank you for the introduction. Today, we're going to talk about confidently build cloud-native applications with serverless integration testing. And as the title implies, today's talk is all about testing and serverless. But before we dive into the main topics, let me quickly introduce PostNL. PostNL is the largest logistics company in the Benelux. In 2021, we moved an average of 1.2 million parcels per day and over 8 million letters per day. And PostNL is on a mission to become a tech company. So we're moving from being a logistics company that uses technology to being a technology company that builds products to do our logistics. We have a full AWS Serverless Mandate, which means that all the applications that we build in-house must be completely serverless. Of course, many, if not all of the applications we build are mission critical. They power our sorting lines and our delivery routes. They power customer-facing websites and applications. And if any of these applications break, a large part of the Benelux might not be able to receive their electronics, books, or shoes. So reliability is extremely important for us. And one of the best ways to assure reliability is through testing, through automated testing specifically. However, the testing landscape for serverless applications is significantly different than the testing landscape for containers or EC2-based applications. Now, my name is Luc van Donkersgoed. I'm the lead engineer for the PostNL integration team. I'm also 12 times AWS certified and AWS hero, and I write articles about AWS serverless on bitesizeserverless.com. And today I will take you through the importance of unit tests, why we can't use unit tests in a serverless environment, and the solutions we designed at PostNL to cover this gap. So first, let's take a look at the famous testing pyramid. It's used in classic software development to indicate the relationship between unit tests, service tests, and end-to-end tests. And the most important distinction in this pyramid is that most of your tests should be unit tests. And that's because they run fast, they run offline, they provide very granular insights into what works and what doesn't. In other words, they provide a very short feedback loop. So here's an example of a few unit tests running on an application. They test a specific function or a small collection of functions, and they test happy paths as well as unhappy paths. And as you can see at the bottom, they execute very quickly. In this screenshot, you see 4 tests executed in 0.02 seconds. So unit tests run very quickly. They offer great granularity, and they really test the application details, the implementation details, the innards of the application. And this is also called open box testing. One step higher in the pyramid are service tests. And these tests also perform happy paths and unhappy paths. But contrary to unit tests, they test the service as a closed service, as a closed box. They only test the integration points, such as API endpoints, and they know nothing about the internal workings of the applications. And contrary to unit tests, they run against a deployed service, where the unit test itself is generally runs offline. So the service under test needs to be deployed before you can run the tests. The tests themselves are generally a bit more complex than unit tests. They only check the integration points of your service. And generally, service tests take a few minutes to run. And because of this, the feedback loop for service tests is a bit longer than what you see in unit tests. Now, at the top of the pyramid, we have end-to-end tests. And these verify that multiple services work well together. So an example would be a payment service and a loyalty service. And the test performs a payment and then verifies that the loyalty points associated with that purchase are added to the user's account. End-to-end tests are the most complex to build, maintain, and run. And they have the slowest feedback loop. They generally take up to a few minutes or even up to an hour to run, depending on their complexity. And of course, they also provide the least granular insights. So if an end-to-end test fails, it's up to the developer to really dive in to see why it failed. So with the basics out of the way, let's look at what this means for serverless environments. Now, a commonly heard mantra for serverless is code is a liability. And this is a bit tongue-in-cheek, but there is some wisdom in it. Because what we mean when we say code is a liability is that when AWS or any other public cloud provider offers a managed service, they will literally run and maintain it for us. They will patch its operating systems and its libraries. They will scale its underlying systems. And when we write our own code, all of their responsibility lies with us. And this is true for network-based technology like RDS or network load balancers or any load balancers. But it is especially true for serverless technology. I mean, if AWS offers a managed service like DynamoDB, S3, or SQS, you can really benefit from using that instead of writing it yourself. I mean, at this time, who is still going to write their own queuing software where you can use the almost infinitely scaling SQS off the shelf? So a non-serverless application might look like the one on the left. It has a load balancing component, a user component, an email component, and a queuing component. And all of these components are built and maintained by your developers. It is code that you own. And you also own the integrations between these components. Now, the same application in a serverless environment might look like the one on the right. It has API Gateway, Cognito, SQS, and SES for email. And to build this service, to build this application, you only build the integrations through configuration and through infrastructure as code. And the integrations are also the only thing that you own. So with these examples, these are pretty, let's say, extreme examples. On the left, you own everything. On the right, you own nothing. And of course, it's a pretty extreme example. In reality, there will always be a mix and match of these. But this example does drive home the point I'm trying to make. And that point is that the solution on the left contains a lot of code that needs to be tested and maintained, while the solution on the right contains no custom code at all. It only contains integrations. And the solution on the left has a lot of unit tests, which really give you insight and fast feedback on the state of the application, while the solution on the right contains no unit tests at all. So let's look back to the 3 types of testing in the testing pyramid. We have the unit tests, which provide fast feedback and granular insight. We have the service tests, which really test the outside of the service. And we have the end-to-end tests, where multiple services are tested together. Now, in a serverless environment, there are really only a few unit tests anymore. They might test the internals of any Lambda functions that you might have, but it's really a significantly reduced amount compared to what you see in a non-serverless environment. We still have the service tests and the end-to-end tests, but they really only test the outside of the service, and they have longer feedback loops. And this leaves us with a gap in our testing coverage. Because how can we still have the granular insight of unit tests, but now on a deployed serverless application? Now, the answer we have to this missing piece in the puzzle are cloud-native integration tests. And these integration tests really test deployed components, such as API Gateway, SQS, or Cognito. And they verify that these services deployed in AWS are configured correctly. And we distinguish 2 types of cloud-native integration tests. The first are the ones that verify if a service integrates with AWS the way we expect. For example, an API gateway might be configured to use IAM authentication. So the integration tests should call the API gateway with an authorized IAM principal, and that should return a 200, an OK response. And then they should test the same API gateway with an unauthorized IAM principal, and that should return a 400 error and an error response. And the second type of cloud-native integration tests are those who really verify that 2 services work well together. So an example might be a Lambda function and an SQS queue. And when you put a message on the SQS queue, it should trigger the Lambda function and lead to a certain response. And the test should perform this action and verify the response. So cloud-native integration tests sit between unit tests and integration tests. Because unlike unit tests, they run in an online environment. But unlike service tests, they test the insides of the application, the individual components of the application. So now that we know what to test, let's take a look at how to test these integrations. The first thing we need is the ability to call specific components of our service. After all, we want to achieve open box testing with granular insight. And that means that our tests need to be able to call API Gateway, to read CloudWatch logs, to invoke Lambda functions, and to read from the SQS queue. And all of these actions means that the testing service or framework needs to know about all of the components in your application, and it needs the permissions to access them. And this makes a strong argument for hosting the testing framework in the same AWS account as the service you're testing. Because if you would apply an external service, it would require very broad access to your service, and probably cross-account or cross-internet access, which is very difficult to configure and maintain. Luckily, the AWS serverless landscape offers a great tool for executing arbitrary functionalities such as tests with a very granular permission system. And you might have heard of this service. They are called Lambda functions. And we can actually use Lambda functions to call one service and to verify the result of your action in another service. For example, a Lambda function can call API Gateway and then verify that the access logs are present in CloudWatch logs. This would verify that API gateway has been configured correctly and that the IAM permissions for the API gateway to write to CloudWatch logs have been configured correctly as well. Now, I'm hearing you think, that's a lot of custom code to maintain again. And weren't we working to reduce the amount of custom code in our application? And of course, you're right. But there are a few arguments why custom testing code is different from running custom code in your production systems. And the first argument is that tests are always bespoke code. There will never be an off-the-shelf solution that perfectly matches all of our testing use cases. And the second reason is that there are really powerful and reliable testing frameworks available that can really do the heavy lifting for us. An example in JavaScript is Jest. And in the next few slides, we'll see examples using PyTest written in Python. And the third argument why testing code running custom testing code is different from running custom code in your production system is that this code is outside of the production loop. Customers will never interact with this code, so the requirements for access patterns and performance are less important. All right, so let's take a look at a test written in PyTest and running in a Lambda function. Our first use case is an API, which is configured with a request validator and a custom response. And we expect that the API gateway returns a 200 response and a simple response body. And as you can see on the slide, we're using the AAA pattern. First, we arrange the test, then we act, and finally, we assert that the result matches our expectations. And now the previous test covered the happy path, but we also want to verify that an invalid request returns a 400 error. So the next test prepares an invalid request, sends it to the API gateway, that's the act, and then asserts that we get a 400 error with the expected response body. Now the previous two slides showed us how to test API gateway as a standalone service. So now let's look at how to test two services connected together. In this use case, we want to guarantee that any API call results in an access log in CloudWatch logs. So we call the API with a known good payload again, and then we verify that the 200 access log line is present in CloudWatch logs. Next, we call the API with a known invalid payload, and then verify that the 400 access log line is present in CloudWatch logs. Now, this test looks a lot like the previous one. The payload is about the same, the test is about the same, but in the first test, we only verified the response code and the response body, and now we're testing using the request ID to look at CloudWatch logs. And you might say those tests can be merged together into one, because, well, there's a lot of overlap. But by splitting it into two, we achieve the granularity that we're looking for, because we can pinpoint exactly what works and what doesn't, instead of one single test that fails and doesn't tell you exactly what went wrong. Now, in this example, the Lambda function needs permissions to access CloudWatch logs. And following the principle of least privilege, that's also the only permissions that this function will get. And that brings us to the next topic, which is scaling the tests. Because for any significant application, there will be dozens or even hundreds of integration tests. And if we would put them all in a single Lambda function, then we would break the principle of least privilege, because that Lambda function would need access to all of your components. And also, PyTest is a single-threaded application. So if we would put it all in one single Lambda function, all of the tests would be executed serially, which could take a very long time. Now, the solution is to create a Lambda function per tested component, also called the system under test. And this function only needs permissions for its own scope, and all of the test functions together can be executed in parallel, which leads to much faster executions. And the Lambda functions simply run the PyTest test script that we saw earlier. So the next question is, where do we store these PyTest test scripts? Well, just like unit tests, we store them as part of our CDK project. So we have a folder called tests, and in it we have a subfolder called integrations or integration tests. And in that you find a number of folders, one for each Lambda function that we have, our testing Lambda functions. And in each of those testing Lambda function folders, you'll find a number of testing classes, which you can identify with the test underscore prefix. And PyTest will recognize these files by their file name and open them to see what is inside. And as it discovers these files, it will find a large number of functions, also prefixed with test underscore. And PyTest will recognize these as test cases and will execute them as part of our test suite. So these tests will be executed by our Lambda functions, but there's more. Because we follow the default PyTest conventions and the PyTest naming scheme, we can actually execute these tests from our local machine as well. And that might look a bit like this. On this slide, you see the output of local tests running on my machine, testing the components deployed in my AWS Sandbox account. And the only thing required is administrator access to that Sandbox account. But as it is a Sandbox account, that is generally not a problem. So let's see that in action. In this short clip, you can see the tests running on my local machine. You can tell that they are a lot slower than unit tests, but still they provide a very short and very valuable feedback loop. The tests being executed look like the code on the left, and the service being tested looks like the diagram on the right. So now we've seen how to test run the test locally, and this allows us to quickly build features and verify that the features work even before creating a pull request. But we also want to run these tests in an isolated environment as part of our quality assurance process. And we've seen how these tests are stored across many different Lambda functions. So how do we orchestrate these Lambda functions to run? Well, when somebody says orchestration in AWS, your first response should be step functions. So that's what we'll use. And on this slide, you see the integration test state machine, which contains a single parallel state. And in the parallel state, you can see all the different Lambda functions, the testing Lambda functions that will run. And as the state machine runs, it runs all those different tests and then collects the results of every single one of those Lambda functions. And then at the bottom, it generates a report of those tests. Any exceptions, execution errors, out-of-memory errors, or timeouts are caught by the parallel state as well, and will be added to the test report as well. So the main goal of integration tests is to test or to verify that the functionality in our service works as expected, and that any features that we add don't break existing functionality. So a good time to validate this is at the time of pull requests, because a PR can run any kind of automation, including a full deployment of our application. And it can also trigger the integration test state machine that we saw on the previous slide. Now at PostNL, we use GitHub Actions for our CI/CD processes. And as you can see on this slide, we have configured our GitHub Actions workflows to first deploy our service, then run the integration tests, and then wait for the integration test to succeed. If all the integration tests succeed, we can merge the pull request. And if any of the integration tests fails, the pull request is blocked from merging. And when all of the tests have completed, the entire stack is deleted again, leaving us with a clean state. So the CI/CD integration does require a few additional steps in our state machine. And at the top and the bottom of the state machine, you can see two new functions. The first one sets the GitHub check to pending, and the one at the bottom sends the test report to GitHub Actions, including the results of every single test. And a real-life example of those tests in GitHub looks like this. So at the top, it states that 23 out of 23 tests passed. And in the middle section, it shows us the names of all the tests that were executed. If an integration test fails, the entire output of the failed test is displayed, including the assertion that failed. And in this zoomed in area, you can see that a Lambda function returned a 500 error instead of the 200 response that we were expecting. And in this example, this was caused by an updated dependency, which is exactly the kind of failure that we're trying to catch with our integration tests. So let's recap what we discussed today. First, the old testing pyramid heavily relied on unit tests. But in a serverless environment, we're looking to replace our custom code with serverless solutions and services as much as possible. And that leads to a reduced significance of unit tests, but it also leaves a gap in our testing coverage. This gap is filled by cloud-native integration tests, leading to the new test diamond shown on this slide. Cloud-native integration tests are best run in the AWS account that hosts the service, which allows the test to directly interact with the AWS services under test. Lambda functions and the testing framework like Jest or PyTest really can do the heavy lifting for us, which allows us to focus on the tests themselves. Orchestration is achieved through step functions, and we integrated our state machine with GitHub Actions, but with a bit of custom code, you can integrate this with GitLab, Jenkins, Azure DevOps, or any other CI/CD tool. And with this test in place, our serverless mission-critical applications can be deployed to production both quickly and reliably. And that allows us to deliver your parcels both quickly and reliably. That's it for me. Thank you.
For a bit. Thanks so much, Luc.
Welcome.
If anyone has any questions, please raise your hand. I will come to you with the mic, and then we just have to all speak very loudly. That gentleman raised their hand first, so I'm gonna come up there first.
Yeah, hello. Thank you for the presentation. Very good. I have a question. It is regarding the usually when you do unit tests, you basically mock your output, let's say, okay? So, but in this case, we have the system running, and then basically if I do a unit test for a request and I want to test only the gateway, it will affect the rest, okay?
Yeah.
So my question is, so how do we manage with the side effects, okay, that will happen in the system? Because then I will run another test that I want to check a message in the queue, for example, but it was the message from the previous test, and this is what makes me a little bit of noise to me about this approach, okay?
Yeah.
That's
So there are two components to it. One is this really works in a microservices environment, and you should test the microservice in isolation. So, for example, if a microservice would do a call to another API, you have to make sure that you have some fixture to mock that API in your integration test as well. Otherwise, you will get all the way downstream issues because of your tests. So that you need some sort of isolation there, but you also need that in your service itself. And we didn't really look at it in this slide, but what we do to solve that is the components. Let's say the smaller domain of components like a Lambda function or a API gateway or a SQS queue is covered by one single Lambda function. And that Lambda function also does cleanup. So if a resource is created, a message is put onto SQS or whatever, the test is responsible for cleaning that out before continuing to the next test. And of course, you can have failing tests, and that can leave you with a bit of junk in your environment. But that's why we delete the entire stack when we're done, so that the next test run is clean again.
First of all, great presentation and a smart way, I think, to approach this problem. My question is, similar to that and a bit related to the redundancy that you see in this approach, because I see lots of overlap of different tests that you're doing, and all of those tests needs maintainability, right? Needs people to sit and write those. I was wondering how you ensure that you reduce the redundancy between all these integration tests by basically introducing cloud native integrations.
Yeah, it's always a balance. So what we see is, let's take 3 levels of testing: unit testing, integration testing, and maybe service testing. All of them have their own benefits, right? So if we have a Lambda function, we just unit test the shit out of it, right? And there's like dozens, maybe hundreds of unit tests on a single Lambda function covering every single path, various inputs to the Lambda function, various outputs, whatever. And then we do a lot of mocking as well, because of course that needs to run offline. But that doesn't guarantee that that single Lambda function that has been mocked and tested to death will still work, or will also work in a deployed environment. So then we deploy it, and then we do the cloud native integration test, but we really test only a few important interactions, like one happy path, one unhappy path, but not every single variant of that, because that has been covered by the unit tests. And then the same goes for the service tests, where we really verify that the service is approachable and reachable from the outside, but we don't go into every detail of the inside functionality, because that is the domain of the integration tests. And then of course there's the end-to-end test, and that's the pyramid shape, right? There's just always less and less and less of them.
Yeah, clear. My second question was related, actually, the sandbox environment that you mentioned. I was wondering why you are not using local stack, for example, which simulates all the AWS for you on your local machine.
Yeah, so it's almost a religious debate, I would say. There's been a lot about written and said about that. I'm really not fond of local testing because it doesn't match your actual deployment, because it is impossible to simulate every nuance of AWS, because that would mean you're actually replicating AWS. And a very clear example is IAM. So you can do go through a lot of trouble to have your API gateway and your Lambda and your DynamoDB locally, and there's no IAM in there. So it doesn't verify that it will actually work in production. And that's really why I focus on deploying in a real life environment. Plus that I think that the maintainability of a local environment itself costs a lot of time. You have to do all the setup and all your containers and all your networking and so on. And if you add a new service, you have to go through all of that again. Well, AWS does that well for you.
Yeah,
it's my view.
No, clear. Thanks.
I have a question about production environment. So you test in the isolated environment. However, when you release something, it's a build artifact plus configuration.
Yep.
So you tested build artifact with some test configuration. However, when you deploy to production, your configuration for production may be wrong, and then the whole thing will not work. So how do you make sure that it works in production?
Yeah. So we've only covered a small part that's really focused around feature development, and that part is deployed in your dev and your test environments and maybe your sandbox. Of course, we also have acceptance and production, where acceptance is a configuration copy of production. And once we've passed all of these tests, then in the pipeline, it will deploy to acceptance. There we will still do our manual testing, user validation testing, and also some other end-to-end automated testing. And if it works there, only then do we promote to production.
Okay, then additional question. You said that it's a copy of production. Does it mean that you have your acceptance environment, like the whole big environment of your whole landscape is one single environment?
Well, yes and no. So within PostNL, we have 20, 30 teams that are responsible for 1, 2, 3 applications each. And each of them are responsible for the dev, test, acceptance, production environment of their application. Now, it might be that the acceptance environment from one application and one team does integrate with an acceptance environment from another team. But I don't think PostNL is a bit too big even for me to know the entire landscape. I mean, we employ 45,000 people, so it's really big. So the acceptance environment of the production environment is not an exact copy of the production environment. Everybody has their own configuration and tests. So there aren't any like end-to-end tests that test the entire landscape of PostNL, because that's just too big for one single test.
Small additional question, but in that case, it means that you actually still have some risk that in production something will not work because you tested everything that you could, but still something might go wrong. Do you do any production tests at all?
Well, we have, of course, our monitoring and ongoing testing in production, like heartbeat testing and so on. But we don't do things like chaos testing or actual testing in production or running test cases. Of course, you can always improve, but also you can't eliminate every single combination of bugs or issues, and we try to avoid production issues as much as we can. But even Google, Apple, and Amazon go down every now and then for the same reason. You can't test every variance of every issue, and at some point you're gonna have to accept that because of the cost benefit ratio between trying to cover everything.
We have one more question, I think, over there.
First of all, thank you for the talk. I'm a bit new to AWS, and this provided a good jumpstart into testing. I was curious about your insights about how to test things that scenarios that are in production, they come up from outside of the AWS network. So when you test using Lambda functions, it comes from the Lambda function inside AWS, testing another AWS service or resource.
Mm-hmm.
So what are your insights into how to test things like customer requests coming from different networks or consumers of the PostNL API and such?
Yeah. Well, you try. This is more the domain of service tests and maybe end-to-end tests. But you try to define every type of interaction. So even before you start building, you have your design of your API, for example, or your Lambda function, whatever, and you know the various inputs and outputs that you can expect, and you can also predict quite a few that you don't expect but might still occur. And you write the test cases for all of those scenarios and then test it. And again, you also have your monitoring and your alerting. So for example, if you have an API gateway and you suddenly see a peak of 500 errors in your access logs or in your monitoring, you have to research, dive deep into what the cause of those 500s were. And if that's some sort of payload that you didn't expect or some malfunctioning application that is using your application, then you need to write some sort of fix to handle that situation. But always when you write a fix, you also write the test to cover that it will continue working into the future, so that when somebody changes something in the future, you know that this specific case has been tested as well.
Okay, so you do depend on your unit tests and cloud native tests, and you see if it fails in production. Then you look through your logs, you investigate, and then
Yep.
you integrate that scenario into your unit tests. And
Absolutely.
Clear.
Yep.
Thank you.
Right.
Thanks. Do we have more questions? We have time for one more question. Oh, no, not you.
Yeah, again, thanks. I think it's a great topic today. It can spark a lot of discussion, so I hope there'll be some catching up afterwards. One question that came to my mind when you were talking about the specific problem, it seems like you're testing a lot of the infrastructure that you're deploying, right? Permissions, like things put into place. So I'm wondering, what is your experience? Like, how specific are those test results? Are the things that you're catching usually things that are wrong in the code, or is it like issues in your infrastructure configuration? And how do you make sure that the error is actually in the sort of service and not in the test itself?
Well, because the tests are mandatory, they must mandatorily succeed. We don't accept flaky tests, or we don't accept a threshold of below 100%. So if something is wrong, if a test fails, we must find out why it fails. What we're really trying to achieve is that the business requirements that we defined work now and work in the future and can't be broken somewhere down the line. So, for example, from an auditing perspective, the access logs that I had in my examples are super important. We must have a guarantee that access logs work. But what if access logs didn't work? The application wouldn't notice because users still do their stuff. The response go in, the response go out, the output in SQS or S3 or wherever still works, but the access log stops. And the only way to verify that that still works is in an AWS account because of the IAM discussions that we had earlier. And that's really what we're trying to cover with these tests. I hope that answers your question, and otherwise let's discuss afterwards. Thanks.
Thank you so much, Luke. Thanks. Give it up for Luke, please. Great talk. Thanks.
Thank you.
Okay, we will take a 12-minute break. We'll be back at 7:30 with our next talk, which is Jerry from IKEA. And so please grab some more drinks, and to everyone on the stream, we'll be back in about 12 minutes.
Yeah. Favor. Could you open me a no comment so I don't have to go when Jerry's speaking? Okay. Can you give me a thumbs up if we ask? Okay. People, please take your seats with us. That always come when you do that. We're live. Okay, we have a microphone for you. Like I say, it's not for use in here, so you wouldn't hear yourself, but it's just for the remote.
All right, and just kind of hold it. Oh, awesome. Yeah, I refrained from the adult beverages before presenting. I figured that was a smart idea. Yeah.
And welcome back, everybody. I hope that you enjoyed your break. We had some awesome food here, and, well, nothing here. It's just nice to actually see people in person. It's kind of really cool. So for our second speaker of the evening, we have Jerry McCollum, who's going to be talking to us about serverless at IKEA. Jerry, please take it away.
Thank you very much. So, Jerry McCollum, I'm going to tell you a little bit about myself at first. I put the senior and senior technology architect, as you'll find out. But I work for Inca Group, and I'm going to explain what Inca Group is, but we are IKEA. Or I guess we pronounce it here IKEA. Is that correct? Yes? And you can tell by my accent where I come from. So I'll tell you a little bit about that story. So just a quick intro of who I am. I was just going to kind of show you my history. So this was my first computer. It was an Ohio Scientific Challenger 1P. How many have one of those? You don't have that. So that was my, it ran Microsoft Basic 1.1, I think. So I started out as a youngin' doing that. In college, I put myself through school working with an orthodontist, and I did this this software where you would like put X-ray on a digitizing pad, enter some points, and figure out angles, and then plot out this thing you put on the X-ray to show how to move the teeth. And I wasn't an expert in orthodontics. There are books that tell you how to do that analysis, but did that for an orthodontist. I started my first real job at Hewlett-Packard, and I won't say the joke I usually do is when HP was a great company to work for, it was. And I started out working on, just like got thrown into HPUX networking commands. So got real familiar with sockets and all the stuff that is now taken for granted with internet. My first enterprise grade project was HP OpenView Network Node Manager. And we had this policy expert. That's still a product. I think it's now part of Hewlett-Packard Enterprises. It's gone through various manipulations. Actually, it may have been sold off to Micro Focus, so not quite sure where it lives nowadays, and presumably all my code's out of it by now, which is a good thing. So I got to work on a consumer product, which was fantastic. I got to be lead engineer on the Windows Home Server project. That was a joint project with Microsoft. So HP did the fancy little box, which you've probably seen that as an icon nowadays for server. And so we had all these like media features. We did a custom front page and configuration wizard, things like this. It was a really cool project and really different to work on a consumer product versus something that you sell to businesses in an enterprise. The one thing that's kind of cool, this was our first actually working with the cloud. Now, this is circa 2007. We actually had the ability to take your files that you had on your server and sync them up to an S3 bucket. But 2007, at least where we were, bandwidth wasn't quite there, so you probably didn't want to sync a whole lot of stuff at that point. So then later in life, I got to work with some hybrid cloud technology. I learned Golang, and we did, I worked for a company called SpectraLogic. They make these giant tape libraries to store petabytes of data on-prem, and we put an interface in front of it that perfectly emulated Amazon S3, and did some policy-based things to decide, do I want it on-prem, do I want it to age into the cloud, things like that. That was 2016 where we did the initial prototype, we being another guy and I. It just became a product in November. So that's a 5-year cycle of idea to enterprise grade product. So then I decided to work a little closer to where I lived, which I'll tell you about in a second, and worked for this company called Nutrient Ag Solutions. They're the largest ag retailer, so they sell to farmers. They're the largest ag retailer in North America. They have like half the market in Australia. They're getting in South America. But they had a digital transformation where we had a portal for customers and employees, and very much your traditional digital transformation type of effort. But I always say that this now feels like the little league compared to being at IKEA. It's major league because the scale, just think about globally how many customers shop at IKEA online and in the stores versus how many farmers are in North America. There's a bit of a difference there. It's a bigger scale. So 2021, I relocated. I spent probably 30 some years in Colorado, where I worked for Hewlett Packard and those companies. We just moved to the Netherlands in 2021. We always get the question, why the hell would you do that? And I'll show you why in a second. So I'm now here working to assist developers, make life a little better for producing software. I brought my wife, my mother-in-law, 4 dogs, 5 cats. 4 dogs, 5 cats costs a lot more than moving a wife and mother-in-law, just so you know that. And the great thing is, I'm now close to, this is the cutest granddaughter in the world. My daughter actually lives up in Leeuwarden. She's been in Amsterdam actually for 5 years, so that was a good reason to come there. So anyway, that's a reason to come over here. I just wanted to give you a nerd alert. This is a little known fact. I can send and receive Morse code at 25 words per minute. Anyone a ham radio geek? Nobody is around here. Yeah, so anyway, so that's me. So I've been doing this a while, and probably, I guess, since that whole effort in 2016 is when I really kind of discovered cloud computing, what enterprises were doing with it. And you'll see that in our journey with IKEA, very similar story as a lot of companies do. So Inca Group, that's actually who we work for. Inca Group is the franchisee of the IKEA brand. And IKEA, and I will mute, does somebody speak Swedish better than me? So it comes from Ingvar Kamprad, that's the founder of IKEA. So his store was his name, the name of the farm on which he grew up, and the nearby village. So that's where IKEA comes from. And what is Inca Group? We're the franchisee, but that comes from his name. So Inca. So I learned that before I talked to my boss for the first time. I thought that was good to know. So that's who we are. And in particular, this campus, we're Inca Group Digital. So we're part of that whole digital transformation of bringing services, migrating legacy systems into the cloud, producing new software systems. And again, talking about serverless and how we try and do that and why it's not as easy as it would usually seem. So Inca Group has 3 business areas, and our core business is IKEA retail. So a lot of systems we work with the retail systems. And as you'll see in my discussion, our retail systems are on-prem at stores, in warehouses, and of course we have systems that work in the cloud as well. And all this, we have 657 million store visitors, 4.3 billion visits to IKEA.com in a year. So you can, this is again from their the public website. You're welcome to go to Inca.com and read more about our company. But the one thing that's great about IKEA that I love so far is our core values. And we really try and live these day to day in how we work. In particular, and I think this is relevant to technology and serverless technology, is cost consciousness is a big thing, a big issue around why we want to use the cloud, and simplicity. You know, the simpler, the better. Complex systems, very brittle, very fragile, too much code. We always try and seek very simple solutions to problems. So that's a little bit about me and the company. So just a little timeline of the journey to the cloud. Of course, I've only been here since this part. So this is from discussions with people who have been here many years and worked with many of the systems here in IKEA. So early 2015 was when sort of that the idea of like, hey, we probably ought to start looking at using the cloud for some of our stuff. And that's when we had some innovation teams form to do proofs of concepts, experiments with Lambdas and AWS. We were using quite a bit of AWS at the time. Lambdas, I think, came out in late 2014. So that was fairly new. And we started to have people using the public cloud for real. But what happened in that time is use of the cloud was just like you have systems you use in the data center, but you just do it in the cloud because it's the cloud. And but there were prototypes and MVPs for how to better utilize that. As 2015 progressed, teams started demonstrating a lot of the benefits of cloud and some of the serverless technology. And we created this principle around cloud first. Again, you'll see many organizations do this, and that is any software project we begin, we target the cloud initially, not like some on-prem or in data center type of solution. So moving on, 2016, start recognizing there's a whole lot of modernization that needs to happen. So you think about how long IKEA's had IT, right? 35 years probably. And you think about the systems that have been brought forward, and then you have integrations on top of that, and integrations on top of those integrations. So you get this real tangled architecture. I didn't grace you with the slide that had a bunch of boxes and a bunch of spaghetti going to other boxes, but you can imagine what I'm talking about. And of course, a lot of monolithic systems and custom integration. So we recognized the need that we needed to move a lot of that to better organized architecture in cloud systems. And so as time progressed, we adopted a cloud vendor strategy. And I'll show you sort of the implementation of that strategy. And again, it would be nice to say we're going to use, we have a primary cloud vendor of GCP, of Google. It'd be great to say it's all Google or nothing, but it's not that simple. And I'll show you about that later, but there is a strategy behind that. And we started seeing, so there are, gosh, Madi, how many teams do you think we have, or Jan? Hundreds of development teams, maybe on that order. And we really value independence and autonomy. And you find different skill levels amongst those teams. So you did have, more skilled teams start adopting a lot more of the modern serverless types of approaches. You had other teams that just really adopted more of like an infrastructure as a service sort of approach. I guess the way I'd sort of correlate this, my company before this at Nutrien, they were in the cloud. It was cloud-based architecture. They were using Elastic Beanstalks, which I don't know if you're familiar with that. They were an AWS shop. But Elastic Beanstalk is load-balanced EC2s behind API gateway, and it really is a very traditional sort of feel to it, as opposed to using Lambdas and Elastic Container Services, things like that. So that was a sort of skill level difference there. But as time progressed, we start bringing in more in-house engineering. So prior to 2019, there's a lot of use of contractors and third-party vendors start doing engineering in-house, focusing on our modernization of our services and software that we have, and using modern approaches for developing new services. And so we tried to, and do now, develop our software as more componentized types of things, components that can be used by other parts of the organization and other systems. 2021, this is interesting here. We have 5 cloud vendors that we use, and actually it's 6 because we're one of the cloud vendors. So we're one of the, if you think about a private cloud, because we have all these data centers. And so because of that, we do have a need when we talk about cloud native and serverless. We have to identify how to do that at a much higher level in the stack. We can't just say, I'm going to implement, you could, and sometimes we do. I'm just going to implement it as a cloud function. You can do that, but we have to have an awareness around what it is that we're doing when we make that decision, so that we know what's going to have to happen as we play into more of the ecosystem. So what are we doing right now? Of course, continuing this transformation of our architecture and that whole component-based approach to migrating our legacy stuff into something more reusable in-house, and a lot of efforts around that. The other cool thing, we started this Cloud Natives Bootcamp. So it's our attempt to take as many engineers and engineering teams at all skill levels through an intensive, I think 9 weeks of training in like hardcore GCP, how to do everything. But we combine that with, and here's how we like to apply that to the way we work at IKEA. So for example, we'd rather team focus on something like Cloud Run versus spinning up their own Kubernetes cluster to deploy containers. So we have a lot of lab exercises around that give our IKEA focus to that training. So that's been really good. We're on our 3rd round of that, and I think it's been well received so far. Let's see, next up, if my clicker will work. Oh, another dialogue popped in that my attempt to connect timed out. All right, now it'll work. So what's our cloud vendor strategy? Well, as I said, 5 cloud vendors listed here, plus IKEA. So our primary preferred cloud vendor is GCP, Google Cloud. We can't serve these 2 countries here with Google Cloud. They don't have regions that serve that in the way we need to meet regulatory compliance and so forth. So China, we use Alibaba Cloud and Yandex over there. So when you deploy a service, you can't just say, I'm going to use an AWS Lambda. You have to think about, well, where am I going to be deploying this? And what service applies to that. Now, not on this chart, you'll see we don't have AWS. We do still have some infrastructure running in AWS, but we really prefer to stick with Google or Azure or the other vendors. So again, independent team decisions, but in our Cloud Natives training, we go through the critical thinking process that you need to make sure you design that properly so that you can move amongst these cloud vendors as needed. And again, as we do that, we try and target our approach towards more of the serverless type of approach versus things that are very specific to infrastructure as service and container orchestration. So it's real easy for somebody like me to stand up here and say that. It's a lot more difficult for an engineering team because they have to implement the right abstractions or the right technologies to make sure that they're going to deploy properly in the regions where they're expected to operate. Let's see. I want to point you to this. So I'm going to talk about 4 sort of principles that we advise teams to internalize in developing in that serverless manner. And a lot of these have technology choices behind them. So if you go to techradar.inca.com, tech radars are used by companies to kind of show you our choices of what we've adopted, what we're trialing, what we are kind of evaluating or assessing, and stuff we decided, hey, hold on, that we're not doing that anymore. So for example, GitHub Actions is in adopt, Jenkins is in hold over there. So won't go through that in detail, but if you're curious about technology choices for these things that I'm going to talk about, that's where you find what we do. So what are these technology concepts that we think are important that people internalize? And I think if I remember, I have 4 of them here that sort of help us design for this ecosystem of those 5 choices or 6 choices that we have for where we're deploying services. So first is an API gateway, and not just like AWS API gateway or Apogee with Google. This is an independent API gateway implementation that allows us to provide that protection of a service to not expose the actual provider system itself with the right protections and policy, but we can host that service wherever and still get things routed. So it makes the location of the service something that is abstracted away from the actual API endpoint. So for example, this year we might have our API running, say in I forgot to say in like the IKEA data center, we are using things like OpenShift. We are starting to use some Knative as well. So let's say I've got a service that's running there. I want to migrate it to the cloud. I can actually do that, and it's just a configuration change in our API gateway to serve up that same service. So that's something that's really important to use in one of these multi cloud and hybrid on-prem cloud environments. Next, a data pipeline platform. So my understanding is we're using StreamSets for this. StreamSets.com is the website. But what this enables us to do is create that sort of data pipeline and data flow across cloud vendors, across on-prem, and wherever you have in the cloud via nice accessible API. And so the big thing here is, you have that data access API, and we have a data catalog. And so, the data catalog kind of tells you where the data is and how to access it, be it in a bucket or BigQuery or wherever. Now, my understanding is that some of this is still in like POC mode, but we're pushing in this direction to make that sort of data pipeline more manageable across all that infrastructure. Next up, event mesh. And this is super important. So, and we have it on the tech radar. We have Solace as our event mesh implementation. And what this lets us do is we've got event brokers that can route event messages across the clouds, across on-prem and cloud. And again, independent of where that service runs, it doesn't matter where the publisher is, doesn't matter where the subscriber is, those services can still operate. So again, using this level of abstraction, if we just based it off of, say, GCP pub sub, there's a way to integrate that with Solace. But if you just focus on one implementation of a pub sub bus, then you lose out on that whole multi-cloud hybrid ability to work across all the infrastructure we have. So again, that whole location transparency is the big win for operating in a truly serverless hybrid environment. Finally, the service mesh. So again, this is the identity and locating of a service, again, regardless of which cloud vendor you're using, which on-prem data center you're talking to. This allows you to access a service regardless of where it is. And for this, again, I believe currently we're looking at Console, HashiCorp Console, to provide that service mesh for us. So again, look towards that tech radar. That kind of tells you where we are in the technology mix. So this, I'm not going to go into details of any of these things, but I think those principles of the technologies we use help us to operate in this overly complicated environment. So I'm going to transition here. These are some of the principles that we share in our cloud native boot camp. And this is more directed towards engineers of things to consider and think about when you're developing in this hybrid multi-cloud and cloud native type of arena. So these are outlined. We have a repository where we have our engineering baseline. And so we don't tell you that you must use, what's a horrible language? You must use, I'm not gonna say, no, you must use Rust and you must talk GCP pubs. Yeah, we don't do that, but we do outline principles that we expect teams to follow. And teams are autonomous and they can choose based on skill sets and what they're doing, they can choose how they want to operate. So I think I have like 8 principles here that we go over in this boot camp. So, the one, and I'm probably preaching the choir, I know, but the big principle around automation. So you automate as much as you can throughout the process, be it your infrastructure, be it your CI/CD, build, test, deploy, your scaling, operational monitoring, and recovery. So the whole thing is you don't want what we call click ops. You don't want any step in there to have to be manual. It should all be seamless from start to finish. And we have several projects that offer like superb examples where it's virtually impossible to check in a breaking change to production because there's so much automation and testing around that. And that's your goal for any of this. So if you can automate it, automate it. In the boot camp, I also throw in the thing, it's that classic chart about when it becomes worthwhile to automate. Usually spend a lot of time trying to automate before it becomes worthwhile. there is a judgment call there, but still, I always, the principle I have around any of this, sort of like the infrastructure as code. Imagine you wake up, of course, I've had this with AWS. I log in the AWS console, I look, it's like, oh my God, all our infrastructure is gone. And it turned out I was in the wrong region. It didn't show me, right? Have you done that? But I always think, well, that's really what automation infrastructure as code, those things are for. What if it all went away? Can you press a button, get it all back? Can you press buttons and have everything go start to finish into production? Of course, microservices, you have independent services. My mom was a big fan of New Yorker cartoons, so I've got these really dumb illustrations. So microservices, they're independent. You develop, deploy, and maintain them separately. That gives us that team autonomy. It supports it. The big thing I like about microservices, done properly, they really reduce the cognitive load. There's only so much you have to understand about the microservice. What I always jokingly call them, maybe it's a little too American, I call them the gazintas and the gazautas. What goes in to the service, that's a gazinta. What goes out of the service, the gazauta. You focus just on that and you really reduce the problem that you have to focus on. Helps you test it better, helps you maintain it better. Of course, faster deployment. I have a anti-pattern that we had at a previous company that had a portal. I won't name the company even though I have. And so we had this microservice. It was a microservice that turned into this giant monolith because when people wanted to add a new set of APIs, oh, well, that's a core level thing. Let's just extend that. And so it turned out this microservice had on the order of, I can't remember, 200 and some odd endpoints and everything from list customer invoices to tell me what the weather is going to be like for this set of farmers. Totally unrelated. And so what would happen is the guys mucking with the weather APIs would check in something that breaks the pipeline. And now we can't get anything through on invoices or users or anything else because it covered too much territory. So just as the previous speaker was saying, very small focused services get you that agility and ability to deploy faster, test quicker, and keep that dependency and keep the breakages from happening in your CI/CD and development pipeline. And of course, they can scale independently. That was the thing about a service that has competing interests. If one needs to scale, it's scaling the whole thing unnecessarily when only one portion of that functionality needs to scale. So that's where that's a really important concept to keep in mind. Of course, containers, that represents my software. So test once, deploy many, and scales easy. It's more flexible for deployment. Again, the previous company, one of the things we did was go from these elastic beanstalks, where it's really difficult to do this testing. The way Beanstalk worked is you would go unit and integration test, but then the actual act of deploying it was take all that, move it, and it copies it to an EC2 and spins it up and does some health checks and things like that. And so then you would find differences in it running in that system versus what you tested. Even the fact that I believe spinning up an elastic beanstalk actually did an NPM install as the first step. So if somebody didn't lock down dependencies, what's running production is completely different than what was tested. By building it in containers, you test it once, and then you know that at least the testing that you've done in that container is ready to deploy in your environments, and then you do more of that end-to-end type of testing. Furthermore, when you do this, you can test that as part of the PR process. It was very difficult to spin up a whole bunch of elastic beanstalks as part of a PR process. Nobody would ever get code delivered if that were the case. Of course, observability, you have to build in telemetry. Here at IKEA, maybe on that tech radar, we use open telemetry. We also use Splunk for log forwarding and aggregation. But we build that in to monitor our services, and that allows that detailed insight, which I can't tell you the number of times where we have a problem in production, and all you do is you go to the tracing. We're a big New Relic shop at Nutrien, and you just go back to, hey, when did it happen? Happened in this time window? Oh, I can see what happened there because I had enough observability. If you don't have it, it's all guesswork. So that's why it's super important for not only getting insights about how to improve it, but also understanding when things go wrong. So stateless components, I figure cats are stateless. So you do it stateless so that your components scale, repair, rollback, and load balance independently without having to know the state of any other instance of that server. So I had a case where I had a team they had a service that needed some caching. They decided to cache within the app instead of with a distributed cache. And so that sounded good and worked fine in their local testing. But when you have 8 instances of that, only one's going to cache whatever request that came in. Didn't work really well. So don't keep the state in the service itself. Use a distributed sort of cache if you're going to do that. Now, I have that stateless. This is my cat this morning. I don't know if you can see. He was stateless. He fell asleep on his food bowl. And he's pretty slow. Anyway, wasn't sure he was alive. So I did check, and he actually did change state. So I don't know if that's stateless or not. Anyway, asynchronous communication. So again, super important to do that event-driven microservice. Again, all your service has to understand is the events it's supposed to emit, the events it's supposed to process, and it reduces that cognitive load, understanding how it's supposed to operate, but it also eliminates tight coupling. And so, again, we had systems where you had a call that made a synchronous call into some legacy system that timed out after like 29 seconds, and suddenly your call breaks. It's like you don't want an API call taking that long anyway. So solution around that is if you use event mechanisms to do that, things can be responsive and you can handle those error conditions independent of a particular API call dependency there. Of course, privacy and security, super important that we protect our secrets and keys. Obviously, big principle there. I think I've seen this in past 4 organizations I've worked in where somebody accidentally checks in an API token or some sort of secret to code. Luckily, GitHub now even has the ability to even keep you from pushing any of that. But always protect that with some abilities to store secrets. That's not PIL, that's PII, personally identifiable information. You've got to safeguard that and make sure you have regulatory compliance around that. As you know, with some of the EU laws about where you can keep data. I have a good friend that was in the healthcare industry. They had to design systems that if I had, even though they operated European wide, any data like from a patient in Ireland had to be stored in Ireland. Any patient in the Netherlands has to be stored in the Netherlands. You can't cross borders with that PII. And that's making sure that you understand what sort of regulatory compliance you're after there. Just a couple more principles here. Choose vendor managed over self-managed just to eliminate the complexity of what your team has to deal with. You don't have to have experts in Kubernetes if you use MGKE versus having your own Kubernetes cluster. I know it's a great simplification, but you can see what I'm talking about, especially if you think about, am I having to maintain a database and backups, things like this, versus use one of the hosted or cloud managed databases. And of course, with the on-prem stuff, that becomes a little more interesting for us because it's kind of hard to find that managed solution for on-prem. One of the principles that seems a little contradictory from what I've talked about with our cloud strategy is vendor independence. And it's not a contradiction. It's really about understanding the specifics of what you're doing with a cloud technology, be it Google, be it AWS, be it Azure, and understand how that compares to other cloud offerings that you might be working with. And also understanding that you might have to make a choice to do something vendor specific, but at least when you do that, you need to do the right abstraction around it so that if you did need to replace that or switch that out, you can do that when appropriate, or at least have the ability to identify where that is so that you can change it out later. One of our principles in our baseline is to maintain architectural decision records. And it doesn't have to be this complicated thing. Just maintain those notes. If you decide, hey, we got to get this deployed in a month, we're just going to use like data store instead of some abstraction, then we write that down as an architectural decision record. So in a year, when somebody says, who decided to write it specific to GCP, well, they made this decision because of these reasons. So anyway, that's one of the things that we try and encourage people to think about when writing software. And of course, upskilling people with that knowledge and developing that critical thinking. So the 2 things I like to say is just because there's a cloud capability doesn't mean you have to use it. Just because BigQuery is there doesn't mean you have to put everything in it. Maybe a file is all you need. And just using a cloud service doesn't make it cloud native. It really is the overall design of the system. And just, of course, because you can use it doesn't mean you should. There may be options that are less expensive and less complex. So those are the principles we try and instill. So I thought I'd do right now, let me see how I am on time. 5 minutes? Does that sound about right? 5 more minutes? So I'll kind of zip through this. One of the things we're looking at, again, our goal here is to, with serverless, is to remove the need for a team to manage infrastructure. There are lots of ways to do that. And we're big consumers of Terraform, but in my mind, Terraform, you still have to understand the infrastructure and where you're placing it, because that's what Terraform does. And so how can we step back from that and bring something to our developers that allows a little more of a serverless type approach? So we're looking at Crossplane. So I'll give you just the high level zip through of Crossplane. Got a great website at crossplane.io. But again, this was our goal. Infrastructure is an API, and not infrastructure is an API like CDK, where you still have to understand the details of the infrastructure, but something where you can use an API to say, I want to deploy a workload in these 3 regions. You decide how to do it. Just make it available, configure the API gateway, configure the event mesh, all that without having to worry about specifics of that infrastructure. And of course, making that self-service, so you don't have to have a team, contact someone and wait, put in a ticket or get help writing their Terraform or, anything else like that. Maximize the utilization of the infrastructure that we have based on the problems they want to solve. And again, some transparency of costs so we can sort of get a better idea of what teams are doing. And of course, immutable infrastructure. So not only enabling that automatic configuration, but the big thing I like about Crossplane is eliminating configuration drift. So one of the things with the whole thing with the Nutrien, with the EC2s, oftentimes to diagnose something, somebody would go in and actually log into a session on EC2, tweak something, hey, it's working, and then what happens after a couple scaling events? It's gone, right? That's configuration drift. And so, you want to avoid that type of thing. So what is Crossplane? So Crossplane's integrated with Kubernetes, but it's not like you have to be a Kubernetes expert to run Crossplane. It provides a universal control plane, and it provides it in such a way that you can use it for cloud and on-prem types of systems. So what's great about this, it's beyond Terraform in that, yes, I can do my sort of infrastructure things I would do with Terraform, but I can also do things with services that are on-prem or that are not really an infrastructure as code type of thing. And it does it through defining resources and creating these abstractions. And so let me check my time, see how, I'll cruise through this. So you do have to kind of, if you want to understand how they put this together, you do need to understand that Kubernetes has this whole machinery with it to provide its APIs for managing the cluster. And it provides an extensibility of that through resources and custom resource definitions. And what Crossplane has done is they've sort of leveraged that so that you write a resource controller in a very specific way so it can work with the scheduler to provision and to monitor that infrastructure. So again, I'll zip through these. Crossplane concepts that build on top of the Kubernetes concepts include the idea of a managed resource. So it's like a Kubernetes resource description, but it's really focused towards, say, an infrastructure type of thing, like a VPC or gateway or database. Again, I'm going to go through really fast. But the big thing with Crossplane is this composition concept. And I think this is what you don't get in some of the infrastructure as code types of things. So and I'll show you a great example. It's straight off their webpage. But you can define these composite resources saying that, well, if I'm deploying this, it's really made up of these like 12 other things that have to be set up a certain way. But as the developer, I just have to tell you, I want one of these. And that composition takes care of the rest of the story. So I'm going to skip ahead because I want to show you how this works. Again, the provider is what sort of implements the guts of making sure your infrastructure is staying up to speed and in the right state. So this is the example that they have on the Crossplane documentation site. So what they have for the developer is a resource that you can configure called a PostgresQL instance. And that sounds really great, but how do you configure a PostgresQL instance? And I think the great example, because it is a little more complicated, is on AWS. You have to set up VPC, you have to set up subnets, you have to set up routing, you have to set up API gateway, RDS instances, security groups, all sorts of things. All the developer wants says, I want a 40 gigabyte database, tell me how to get to it. And so this is an example of composition. Now I want you to memorize this, there'll be a quiz. I'm just joking. So this is a description of how it can provide. If you scroll down with your eyes, there's a kind called XPostgresQL instance. So this is a one of these composition resources that says, if you want to provide a PostgresQL instance and you want to do it on the provider up there, AWS, here's how you do it. You have a VPC, you have a subnet, you have more subnets, you have subnet groups, internet gateway. There's about 2 more pages of this. Again, this is all from the Crossplane website. But you can see what they've done is they've said, but when you configure this VPC, here's the CIDR block. When you configure the subnets, they're in this region, they do all this. That's all in there. Developer doesn't have to know that. Developer doesn't have to worry about that or copy from some other repo what somebody else did with their Terraform. This is what the developer has to do. They say, I want a PostgreSQL instance, name it this, storage is 20 gigabytes, it's on AWS, put the secrets to how to connect to it in this secret reference there. That's it. And so in the Crossplane getting started documentation, and you can do this, I run it with Rancher Desktop or Minikube. It really shows you this power of composition. So what we're trying to look at is this a way for us to build infrastructure API that lets us serve that complicated landscape that's on-prem, that's multi-cloud, where developers can say, I need this. I don't even want them to specify a provider, maybe say it needs to serve the EU and China. And then we have the right compositions in place for them to accomplish that. And so what that does, again, the platform consumer here is going to be your developers. You do stuff to have a team that understands how to put all that together. But you've now isolated that knowledge and made it common. So let's say they've decided there's a new rule on how they want to provision, say, a security group or subnets. They change it in that composition definition, in that resource definition, push that out, and everything updates according to your versioning scheme and so forth. And the developer didn't have to do anything. It can be managed by the experts on that infrastructure. So anyway, that's a little bit about what we're looking at for the future here, and be glad to take any questions. That is it. Thank you. Thanks for your time. So I should put up the thank you slide.
Yeah, well, I'll just say it instead.
Yeah.
Thank you. Thank you, everybody.
Thank you.
That was an awesome talk. That was so much information.
I know,
in
and
a
I
short
talk fast.
amount
Sorry
of
about
time.
that.
It was awesome. Thank you. Do we have any questions for me to run around this stairs and carry a microphone? Dag, let's beweging people.
Thank you for your talk. Very interesting, both broad and going deep. I imagine a big reason for adopting a multi-cloud strategy of IKEA is regulatory reasons.
Exactly.
Especially probably China.
Yep.
Do you have an estimation of how much extra work it is to do it multi-cloud instead of single cloud?
I don't, and that is because I've queried engineers. So not every team is going to deploy in China. So because we're franchisee, even the operation of stores in China is different from the way stores operate here in the EU or in the US. So not every team has to deploy to China. So I really don't have a good feel for how much of that is there. I will say that our cloud native services are more limited in Ali Cloud than they are in GCP. And so if we look at things like Knative or whatever, my thought is if I could run Kubernetes cluster in Ali Cloud and I can have it use Knative or even Anthos, I think, is Google's managed Knative that provides cloud run type of functionality. I think so does Knative. So then that gives me the ability to have a very similar deployment model regardless of the region. So that's sort of the goal that we try to get to. But that's a hard question. And yes, it is because of where it needs to sit on either side of the Great Firewall, where data, regulatory about where data is stored for that. And I'm sure that there'll be other issues like that in the future with other regions and countries as well.
Yeah, that's clear. Would you think it's more or less than 50% premium? For example,
I would
spending 40 developer hours.
Jan, what do you
or
think?
60?
Less?
Less?
What do you, from your experience, Mon? Yeah, so a lot of teams here are developing things that don't execute in China. What's your thought, Jan? Mm-hmm. Yeah, what Jan's saying, for those who might not have heard, is we do use Artifactory to replicate container images and so forth into that environment. But my gut feel is it's less than 50% at this point. But I'm oftentimes wrong. So, but you didn't hear that here.
I think that's pretty good.
Yeah.
Yeah. Thank you.
Thank you. Very good question.
Any other questions in the hall? Yep. I don't even have to run.
I also have a question about some reusability, but let's say we're talking only about one cloud,
Mhm.
but exactly as you said, you have a presence in the USA and in Europe, and there are different, I don't know, something is different in some particular types of workflows.
Yes.
So it's kind of the same but different.
Yes,
how,
and
how do you approach it?
Yeah, and so that's, again, unfortunately, something you have to understand. For example, there are features Azure has hosting in China, but it's not as feature rich as Azure in the EU. I assume there are also differences between from region to region in the other services. So that's where I think we do need, you still, for the time being, have to have teams understanding the details of the cloud providers so they can, or at least someone on the team, so that they can understand the trade-offs that they would have to make in that case. And again, the regulatory compliance. But my hope is that we can hopefully pull some things together to eliminate that as being something that has to be worried about. I think you always have to be aware of it. I mean, it's irresponsible to develop a service and not really know where the data is going to be stored and what the data flows are. But yeah, that's me rambling, not really an answer, but it's a intricate question. Yeah. Mm-hmm. Yeah, and just to repeat that, we have relationships with our cloud vendors very good, so they might give us early access to some of the capabilities that might not be ready for the general public, and we'll sort of help them get that more mature for the broader audience.
And what about more abstract level, like next level? For example, there is a value chain, and the value chain in the USA and in Europe is pretty much the same, but actually parts of the value chain is different. So it's less about the infrastructure and servers and clouds. It's more about services itself.
Right.
How do you approach this?
Yeah, and that's and that's where I'm hoping that by providing an infrastructure API with some of this composition, that we can remove those concerns from the development teams, and they can just say, I need to be in this region. And then the people that really understand how services execute in those regions on the various infrastructures, they take care of that as part of the configuration of the composition. And I do understand I might be a little more hopeful about what Crossplane can do now versus the full vision, but that's where I think that the power comes, is really taking those types of decisions, not taking away from the developers, but letting them focus on the business at hand instead of intricate details of infrastructure and where things have to be and how this has to work versus that. Put that in a team of experts on those infrastructure, on the cloud vendors and infrastructures, but let the developers do what they do best and solve the problems.
Thank you.
That's the hope.
Thank you. Any other questions? Yeah.
Sure.
Yes, hello. Just a question related to we have this kind of abstraction, okay, to select from different providers, okay. That's very nice, but then you have because I see in many cases you have many options, okay. Then what's the criteria to select one or the other, or where I will put my services? Because in general, people, they decide for one or the other for
Yes.
the specific details they have, okay. If you
Yes.
are putting the abstraction, then you are losing that decision, let's say,
Exactly.
criteria, okay. So
Yeah,
how
and
do
we have teams. So just so you know, we have teams. It's not an easy subject. We call it workload placement. So given the nature of a particular workload, where and how do you place it in what way in whatever infrastructure? So there is the case where yes, you need to put the decision making ability about that with the experts, which may not be the developer team. There's nothing. So the other thing about the way compositions work and so forth, there's nothing that says you can't have an extra offering that allows the tuning of your thing you're requesting to be more specific to the needs of the team. So I can have 5 different, not that I want to, but 5 different compositions of Postgres, each with a different purpose or different parameter about how it's going to operate or where data is going to be or whatever beyond just the provider. And we could provide that for our teams so that, again, the intricate, intimate details about how to do that, they don't have to worry about, but the experts in that infrastructure and the cloud technology know how to do that. But yeah, it's not a magic bullet or miracle pill. There is a lot of thought, and that's actually one of the things I'm thinking too. It's great to have a technology, but then there's how do you actually operate that in production in an enterprise environment, and it goes beyond just the simple Medium article 5-minute read example, right? So you do have to get to that level of detail and understand what has to be provided if we're going to do that. So,
okay.
very good question.
Thank you.
Thank you. Any more for any more? Yeah.
I believe in continuation of previous question. So let's say I'm a developer and you are helping me to not to worry about a lot of things, but then I don't really know all these things, right? They are all magic for me. And in your case, do developers care about how does it operates in production? Do they care about any?
So I think that's a very good point. And again, this is future, but that's one of the things that we have to look at. We have to be able. A team can't just like throw something out there and hope everything goes well. Just those principles we had with observability and traceability, you've got to have a story for that. So ultimately, yes, they're going to have some way to know how that's running and know where that's running. So I think that's sort of the open question for us is, so if we do this, if and when we do this to a full level, what do we need to provide teams so that they can responsibly own their service and its operation in all these environments? Because you're exactly right. You can't just hide absolutely everything. You just want to make their life simple. It doesn't mean that they have to be totally oblivious to what's going on. So.
Right. So the
Yeah.
autonomy is one of the keys for the teams. So if we are fully actually able to do whatever we want with the instruction we have, with lots of actually resources and documentation we have, and then you can also introduce new things, but there are procedures. But also each team has a dedicated enterprise architect to help with all these complexities and all these questions. So even if you have the tools, but it's still you have a mentor to help with all these questions and all these actually practices in place.
And it really is. With that autonomy, you need, if we're going to do something like this, you have to provide those choices. So you don't want to take away everything and say you must do it. That would never fly just culturally within IKEA. But we do want to say, just like we have, there are many people in the company very, we like that Netflix model of the golden paths. Like, hey, here's some great examples of how to create a service, operate it in production, and so forth. And there's a lot of sharing and of that sort of information, various Tech Guild, Slack channels, things like that for best practices. But ultimately, the team decides how deep they want to go with something and what they want to do. So I think it's provide something that is, if a team wants to say, hey, we want to focus on creating value and solving this problem, great, that's there and works for us. But if we have a lot of people that have a real rich DevOps background, they want to know the full details. Nothing about cross-plane necessarily hides that from you, because you can create your own compositions. You can override some of those parameters and some of the actual composition itself. But again, it's providing that range of options so that for the teams that want the easy route, we have it for them, but we're not preventing them from going as deep as they want to.
Thank you.
That's a great non-answer for you. It really, the autonomy really does present a whole host of problems. It's totally different in a smaller company where you can say, you're going to do it this way, you're going to do it this way, you're going to do it this way. I would be sent into one of the canals if I started doing that here. So, yeah. Mm. Mm-hmm. Yeah, yeah. Yep. Yeah, supporting those different levels of maturity across all the teams.
Okay, and we have time for one last question.
Yes.
Yeah, so I'm a software engineer at IKEA myself.
Awesome.
So it's
Welcome.
been great. I've always seen you around the office, but I've
Yeah.
never heard you speak. This is great.
What is that thing? Anyway, yes.
Yeah, but you mentioned earlier the tech radar of Inga, and it's something that when I joined, I thought it was very cool to see exactly where we are, and that IKEA is very open and keen to try and experiment with new technologies. And to be honest, hearing about crossplane today is the first for me.
Yeah.
But I would also like to ask you, like, you seem to be very comfortable with crossplane, and it's something that I think in your day-to-day you have a lot of contact with. But what's your view on how that is on the technical radar of IKEA?
Okay, that's a good point. So it does actually show up on the tech radar in one of the hundreds of dots that you see there. And just the tech radar is really supposed to be sort of a guide for us. Oftentimes people say, oh, it says we can't use this. No, it doesn't say we can't use it. It says not many teams are using this. Or it says we have to use this. No, it's saying a lot of teams are using that. So that's something I understand about tech radar. But what I see with crossplane, it's something I just did a POC on, I think, over the holiday. So it's fairly new on the scene. I still think that there's the way I look at it is you don't just like go whole hog into it. You start applying it where it provides some value. One of the things that I did was a provider for our Solus event mesh, was had a very ClickOps way of configuring queues and topics on the event mesh. With this, I create a very small YAML file, push it out there, and behold, it's done. Now that's easy for me to do a POC, but actually deploying in production, you have to have who's managing the permissions, who's managing the credentials, how does that actually happen, what's monitoring the repo to push that. There's a whole lot of operational detail that has to go into that. So I think crossplane, I think it's sitting in the assess bucket, but I think it really does take, and I've said this from the start, either you got to decide to do this or don't just do it halfway, make it something that's actually useful for teams. Otherwise, it's just another blip on a tech radar that gets ignored. So hope that helps.
Yeah, thanks.
Yeah. And I think I didn't mention it's a CNCF incubation project. So it's even younger than things like Argo CD and can't remember what else is beyond that. But anyway, thank you for your time and for listening to me. I'm surprised there are no questions about the Challenger 1P computer, but I'll be here to answer questions about that later if you want. Thank you very much. Appreciate it. Thanks.
Thanks so much, Jerry, and thanks all of you for coming, and thanks, Luke, for your talk earlier. I would have a question about the Challenger 1P if I was born in 20 years before my time. Anyhow, yeah, this is the end of our first hybrid meetup. That was great. Thanks all for helping us, also with passing the mic around. We'll see how it turns out in the end. I'm going to watch the stream later to see if anyone actually saw anything. But
you guys have also been awesome. And again,
sure.
thank you for coming here. Please, applause for yourself.
yeah. So yeah, if you want to speak yourself, if you know of a company that might want to host us in their offices, if any companies still have offices, not sure about that. If you want to help us organize a meetup or the conference or anything else, anything you want to talk to us about, you can get in touch with us. Amsterdam@ServerlessDays.io. You can hit us up on Twitter. You can go to the Discord. You can talk to us in person.
We don't bite.
Yeah, pigeon, mail, I don't know, anything. Just try it. Just Google Serverless Days Amsterdam, and you will probably get to us. Any last parting words, Stace?
No, just again, thank you so much for joining. Thanks to our two awesome, spectacular speakers.
Yes.
It has been amazing to see people again. I've started to go to in-person conferences, and every time it just really makes me want to bounce actually seeing people. So thank you so much for making this a great evening.
Thanks, Federica, for helping us organize this meetup here.
And the amazing food.
Yes, and the very yummy food. I was surprised by the size of the hot dogs here.
When somebody said hot dogs, I was
bigger than what I
expecting
know
something
from
like this.
right. We still have a bit of time to sit here and to drink a little bit and mingle, but we'll be kicked out at, I'm gonna say 9:30. It's gonna take a bit longer, but I'm gonna say 9:30. So yeah, enjoy the rest of the time and thanks for coming.
Thank you.